Linear inequalities. We're going to take a look today at how we can graph a linear inequality. And first, some notes about this. When I say I want to graph something, what I'm really saying is I want to make a picture of the solutions. That's all a graph is, a picture of solutions. Now with inequalities, they have many solutions. If we've got something like x is less than 2, that means x could be anything less than 2. It could be -4, 0, 1. It could be an infinite number of things. So instead of listing all the solutions, we'll make a picture of the solutions by graphing our inequalities. Now when we're graphing the inequalities, here's some tips that we can universally agree on so we know what they represent. When we're dealing with strictly less than or greater than, you will often see an open dot at the value that we're less than or greater than. But if we add the or equals to show that I could equal that point, you will see a closed dot at the point. So the closed dot is for equals to, the open dot is for strictly greater than or less than. Then we'll add an arrow either left or right off of that dot in the direction of the solutions. So if you're ready to be a champion and stay strong, you will be done graphing if you can follow those steps. Let's try a few examples. I have 6 examples on here. The first example says x is less than 3. So first I'm going to less than or equal to 3. So I'm going to start with a little number line here. And it doesn't have to be too incredibly detailed to get the point across. 3 is to the right of 0. So that's probably sufficient. And because this is or equal to, we're going to use a solid dot at the 3. And because x is less than, it is smaller than the 3. We want all the values smaller than 3. So we will shade to the right and put an arrow showing we want all the values smaller than 3. Second example says that x is greater than 1. So we'll make a really quick sketch of a number line. 1 is bigger than 0, so that just gives us some reference. But this one is strictly greater than. So because it's not or equals to, we will use an open dot at the 1 to show that I can get as close to 1 as I can without being equal to it. And then you'll notice that the x is bigger than the 1. It opens to the x. So we need to graph the bigger side of the number line where the bigger numbers are, which means we're going to make an arrow to the right. This third example says x is greater than or equal to -2. -2 being to the left of 0. It is or equals to, so we will use a solid dot to represent the or equals to. And this time, because it opens to the x, we want bigger values. X is bigger than the -2, and so we shade the bigger side of the number line with the arrow at the end. Our fourth example, x is less than -3. Well, -3 is off here to the left. It's strictly less than, not equals to, so we will use an open dot. But this time, it points at the x, signifying that the x is smaller than the -3. So we will shade the smaller side of the number line. Now with these first 4 examples, what people often notice is if we think about the inequality as an arrow, it kind of shows the direction that the graph should go. However, that can get us into trouble if the variable is on the right side of the equation. These last 2 examples, the variable's on the right side of the equation. So I want to be careful here with how we draw these inequalities. Here, 2 is greater than x. 2 is greater than, it's not equal to, so we're going to do an open dot. But because the 2 is greater and the arrow points at the x is actually smaller than the 2. Because the x is smaller than the 2, we need to shade the smaller side. And what you may notice is that goes the opposite direction of the arrow. If I made that into an arrow, it would go the opposite direction. So that's why I don't like to think about the inequality as an arrow. We really need to think about what's bigger and what's smaller. Is the variable bigger or smaller? And that's the side of the number line that we shade. With this last example, -1 is less than or equal to x. Because it's or equal to, the -1 gets a solid dot. The -1 is less than or equal to x, but the inequality opens to the x, signifying the x is bigger. And so we're going to shade to the right with our arrow. And now we have graphed a picture of the solutions for each of these inequalities. Now, sometimes the picture is a little bit much to depict, especially if we're on a computer or we're writing out the solution set. So to help us, we use something called interval notation, which represents the graph with numbers and symbols. Here's what I mean by that. For a less than or greater than, we're going to use curved parentheses at the value. If it's or equals to show the graph was or equals to or a solid dot, we're going to use these square brackets to show the or equal to value. And because our arrows often go off forever either to the left or to the right, we need something to represent infinity. We use what looks like a sideways 8 for infinity and a minus sideways 8 for negative infinity in what is called interval notation. And because we can never exactly get to infinity, we're going to always use curved brackets for our infinity. So for example, here's 4 graphs that I've prepared for us. All of them hit the number 4. I'm going to use a different color than blue so it stands out a bit. How about green? They all hit the number 4, but this one goes off to the right all the way to infinity. The way we show that with interval notation is because we're not equal to 4, it's an open dot. We'll use a curved bracket at 4, comma, and it goes all the way to the right to infinity. And this tells us the graph goes from 4 to infinity, and it's an open dot because of the curved parentheses. So curved parentheses for the 4, comma, infinity. We can kind of see it right on the graph. The second example also goes from 4 to infinity, off to the right. But this time, because of the closed dot, we're going to use a square bracket for the 4, comma, then the infinity will always have a curved bracket. So the second graph is square bracket 4, comma, infinity, curved bracket. The third example, you'll notice, starts all the way off to the left here at negative infinity. It goes forever. But it stops at 4. Because we're not a solid dot, we're just less than, we're going to use a curved parentheses for the 4. Infinity always gets a curved bracket. And you notice the interval notation's always read left to right. This graph goes from negative infinity up to 4. Another example here. Again, it goes to negative infinity, off to the left, which always has a curved bracket, comma, but it stops at 4 with a closed dot, meaning we're or equal to, so we need a square bracket. This graph goes from negative infinity to 4 with a square bracket. So interval notation simply is numbers and brackets to represent the graph or picture of solutions to some inequality. So we can either make a graph, or we can make interval notation, or sometimes we do both to look at the picture of solutions to the inequality. And that's all there is to graphing inequalities. Take a look at your homework assignment to try a few. Ask your instructor if you have any questions, and I hope you found this video useful.